All right, now that we've looked at binary and talked about how computers use that binary system to store and transmit data, we want to look at the hexadecimal system, mainly because once we start really getting quicker computers and being able to store more data, we need a more efficient way of doing that. So after this lesson, you should be able to convert decimal numbers to hexadecimal and hexadecimal to decimal. So why do we need more number systems? Well, we're used to the decimal system, right? We have 10 fingers. It's pretty easy to count 10. So that's what most of our counting is based on. But computers don't understand 10. They understand binary. But computers are also getting bigger. They're getting faster. And they are needing to be able to move more data. And so we have computers that have 32-bit buses, and we have 64-bit buses, and we even have 128-bit buses. And so displaying these numbers in binary gets a little bit messy. So just in general, a data bus is a way of transferring data within and outside a computer. So you can think of it as an actual bus. If we send one bus to the computer, we are sending one bit of data. And this can be a pretty slow process. So when we build a computer that can receive 32 buses at a time, or one that can receive 64 buses at a time, we can send a lot more data. So as our computers get bigger and faster, they need to be able to handle more data at a time, or really being able to handle more buses at a time. So sending data in just binary form becomes cumbersome. So we can take that binary code and we can compress it into other forms to make the data transfer more efficient. Hexadecimal is one of the ways that we do this, and it uses a base 16 instead of a base 2. Hexadecimal is a base 16 number system. Decimal is Latin stem for 10, and hexa is Greek for 6. This means that we are going to need something to represent digits up through 15. Well, our number system only has 10 digits, so we're going to have to resort to using letter representations for the numbers 10 through 15. Here's what this looks like. The numbers 0 through 9 are all represented by their corresponding digits. But once we get to 10, there are 2 digits, and we need to represent that with one character. So the decimal number 10 is represented in hexadecimal by the letter A. 11 is represented by B, 12 C, 13 D, 14 E, and 15 F. Converting to hexadecimal numbers is done in the same manner that we converted to binary. Remember, binary is a base 2, so each place value used 2 to each power. Hexadecimal is base 16, so we are going to use a power of 16 for each place value. The first place value in any number system is going to be the ones place. Remember, that is because any base to the power of 0 is going to be equal to 1. Every digit here is going to represent a group of 1, just like it is in our decimal or our binary systems. The next place to the left is going to be 16 to the first power. So every digit here represents a multiple of 16. Move another place to the left, and now we have 16 to the power of 2. So each digit here represents a group of 256. 16 to the third power is 4,096. So each digit here represents a block of 4,096. You can probably start to see now how much more data we can store in each digit by using this hexadecimal base. So let's look at the decimal number that this hexadecimal number represents. The first place is the ones place, and there's a 7 there. So this represents 7 groups of 1. The second place has the digit 2, and it represents how many groups of 16 that there are. That means that a 2 in this place would represent a total of 32. Now this third place is the letter A. Remember that we need to start using letters when we get to the 2-digit numbers. So A is going to mean that we have 10 groups of 256, which gives us a value of 2,560 from the third place. There is a 1 in the fourth place, thank goodness. The fourth place represents 4,096. So we have one group of 4,096. Add all of these values together, and we see that 1A27 in hexadecimal represents 6,695. So pause your video and convert these hexadecimal values to decimal numbers. So now let's go the other way. Remember when we were converting binary, we divided the number by 2 every time and used the remainder to determine the binary number. We're going to do the same thing to convert from a decimal number to a hexadecimal. Start with a number we want to convert, in this case 3,567, and divide it by 16. 3,567 divided by 16 is 222, and it has a remainder of 15. So take 222 and divide it by 16. You get 13 with a remainder of 14. 13 divided by 16 is 0 with a remainder of 13. We are again going to read our remainders from the bottom up. 13 in hexadecimal is represented by the letter D, 14 by the letter E, and 15 by the letter F. So the hexadecimal representation of 3,567 is DEF. Let's try 429. 429 divided by 16 is 26 with a remainder of 13. 26 divided by 16 is 1 with a remainder of 10. 1 divided by 16 is 0 with a remainder of 1. Again, start from the bottom with 1. 1 in hexadecimal is 1, so that is our first digit. 10 is represented by A, and 13 is represented by D. So the hexadecimal number for 429 is 1AD. So pause your video and convert these decimal numbers to hexadecimal numbers. Okay, now what about the color red? You may have noticed at some point that changing the color of your font or pixels shows the color of a weird mix of letters and numbers. Ever wonder what those mean? Well, remember that we represented the color red as the binary number 11111111, zeros and then zeros, or 25500. So I wonder what 255 is in hexadecimal. 255 divided by 16 is 15 with a remainder of 15. 15 divided by 16 is 0 with a remainder of 15. 15 is represented by the letter F. So the red portion of the code will be FF. There is 0 green and 0 blue. So the hexadecimal number for the color red is FF0000. Now open up a Google Doc and type your name. Go up to the font color and choose the custom option. Type in FF0000. What color does it select? Well, you should get pure red. What color do you think you will get if you type in 00FF00? Think about your RGB color code here. We would have 0 red, we would have 255 green, and 0 blue. So 00FF00 is the color green. Try 0000FF. No red, no green, and all blue. So you should now be able to convert decimal numbers to hexadecimal numbers, and vice versa.